This is Professor Kyle Mack, and you are watching 12-4 Lesson Intro in 5 minutes or less. Our learning tasks for this section are proportion properties, slope, and perpendiculars and parallels in algebraic geometry. Proportion properties have two main concepts. There's similarity properties and then the solving missing measures. So the two similarity properties that we have are side, side, side. That states that when three corresponding sides of a set of triangles have the same proportion, then that set of triangles is similar. Side angle side states that if there are two corresponding sides that have the same proportion and there's an included angle, meaning an angle between those two sides, and those angles are congruent, then therefore you have a set of triangles that are similar. Now, once we've established that we have similar triangles, then we can start looking at solving missing measures. And what we do is we just use the proportions that we can set up to solve for that missing measure. So for example, if I have 3 and 6 as proportionate sides or corresponding sides that are proportionate, that is a 1-to-2 ratio. We can see that 3.5 and 7 have the same 1-to-2 ratio. Therefore, 4.2 and y should have a 1-to-2 ratio. You set up the proportion below here, and therefore y will equal 8.4. Now we look at slope. First thing that we need to know about slope is its formula. The slope formula is m equals y2 minus y1 over x2 minus x1. There are many ways that we can talk about slope. We could call it rise over run. We could call it change in y over change in x. The next thing that I want us to look at is how slope has a relationship with similar right triangles. We look at all of these triangles here. These two triangles are congruent, but this triangle right here is of a different size, but it is the same shape. Those are right triangles. We see a 90-degree measure in each of those triangles. And we also, understanding that slope is rise over run, we can take the rise measure and the run measure of that triangle, and then the rise measure and the run measure of the similar triangle. And what we'll find is we do have similar right triangles there using the side angle side postulate. And what we really are doing is we're seeing that the hypotenuse of all of these similar right triangles makes up the slope of that line. And then we look at the slope-intercept form. This is the form that we use in algebra to set up any linear equation. It is y equals mx plus b. M is the slope, hence why we use m up in the slope formula. And then b is the y-intercept. That is where the line will cross the y-axis. Here is that exact point, and that would be 0 in this particular situation. Now we come to perpendicular and parallels in algebraic geometry. What we're going to see is whenever you graph an equation, when there is an intersection or no intersection of two sets of equations that are graphed, then we have certain situations. Parallels are when there is no intersection. We will find that they have the same slope but different y-intercepts within their equations. Now, when we look at perpendicular lines, that means they intersect at 90-degree angles, we'll find that there's something really cool that happens with their slope. Their slopes are going to be negative reciprocals of one another. A reciprocal means you take the fraction and you take the numerator and it becomes the denominator, and the denominator becomes the numerator. And then opposite just means that it's either, if it was negative, then it becomes positive, or vice versa. And so therefore, you can see a picture right here of two equations, and then those two equations are graphed. And you'll see that their slopes are negative reciprocals of one another. Now, when it comes to the y-intercept with perpendiculars, we don't need to worry about it because the y-intercept doesn't matter. It could have the same y-intercept. If it does have the same y-intercept, then there's a special situation where that is the actual point where the lines intersect. And that concludes our 12-4 lesson intro in 5 minutes or less.